Hello everyone. This video is a reflection on the evolution of GPUs, their applications in intelligent driving vehicles, and the emerging concepts of digital twins and the metaverse. I'll be sharing my thoughts on how GPUs have transformed computing and enabled artificial intelligence and what this means for the future of technology. We'll also explore the acceleration of GPU development, its impact on real-world applications, and how, as future engineers, we can use these advancements responsibly and effectively. So yeah, let's start by looking at how GPUs evolved over time. GPUs, or graphics processing units, were first designed to handle graphics-heavy tasks like rendering 3D images, shading and lighting for video games and simulations. At that time, they were mainly seen as tools to make games look better and smoother. But over the years, GPUs became much more than that. Their massive parallel processing capability allows them to perform thousands of calculations at the same time. Unlike CPUs, which are designed for sequential processing, GPUs are optimized for tasks that can be done in parallel, like the huge number of calculations required in artificial intelligence. And a turning point came when developers started using GPUs for general purpose computing, and frameworks like CUDA or let's say the CUDA made it possible to leverage GPU for non-graphics tasks. Suddenly, GPUs were running scientific simulations, complex mathematical models, and AI algorithms. It's honestly fascinating to see how a technology initially intended for entertainment has become the backbone of AI. And for me, this really demonstrates an important lesson as a future engineer. Innovation often comes from finding new applications for existing technologies. Something created for um, one purpose can become essential in entirely different fields. Pretty cool, right? And the second video highlights the role of GPUs in intelligent driving vehicles. Autonomous cars are essential mobile computers with multiple sensors like cameras, radar, LiDAR, GPS, all sending massive amounts of data every second. And all this data has to be processed in real time. Imagine that. That's so much and a lot to process. And GPUs play a critical role here. Their parallel processing power allows autonomous vehicles to recognize objects, detect lanes, predict the movement of other vehicles or pedestrians, and plan safe paths, all simultaneously. And without GPUs, this would be almost impossible. And moving on, watching this video made me realize just how interconnected software and hardware are. Writing an advanced AI algorithm is great, but it needs hardware that can handle the workload. GPUs bridge that gap and turn AI concepts into real-world solutions. As future engineers, we need to remember this. Understanding hardware architecture is as important as developing software. And we have to optimize both to create systems that are intelligent, safe, and efficient. And honestly, that's kind of exciting. It shows how much opportunity there is in this work, or rather say, in this field. So, the third video explored whether technologies like the metaverse are real or just hype. Thinking about it, I realized that digital twins and metaverse are already starting to impact industries. Digital twins are virtual replicas of physical systems, from machines to entire cities, that allow engineers to simulate, monitor, and optimize operations. The metaverse, on the other hand, is a shared virtual space where people can interact, collaborate, or and even work, blending digital and physical worlds. Both of these rely heavily on GPUs for real-time simulation, realistic graphics, and AI-driven interactions. GPUs make it possible to render complex environments, run AI agents, and process data simultaneously to create immersive experiences. And it's actually amazing when you think about it, right? And from my perspective, these technologies are more than hype. Um, they are emerging realities that will change how we work, learn, and interact. As engineers, it's our job to explore how to leverage these technologies responsibly to create meaningful applications, not just for entertainment. So let's move forward to reflection and future insights. So looking at the evolution of GPUs, autonomous systems, and emerging virtual worlds, several things stand out. First, GPUs have transitioned from specialized hardware for graphics into fundamental computing infrastructure for AI and simulation. They are no longer optional, they are essential. Okay. Second, the acceleration of GPU development will continue to unlock new possibilities, and we can expect more powerful GPUs with specialized cores for AI, ray tracing, and simulation as well as increased um, memory and interconnect speeds. And these advances will support applications such as real-time digital twins of cities, immersive metaverse environments, and autonomous systems that can um, learn and adapt in a complex real-world conditions. And the third one, as a future engineers, we have both an opportunity and a responsibility. We can innovate and build technologies that improve safety, efficiency, and quality of life. But we must also consider ethical implications, sustainability, and societal impact. And autonomous vehicles rely on GPUs for safety critical operations. Metaverse platforms rely on GPUs to manage data responsibly. We have to think about all of this while designing the systems of tomorrow. It's a lot of responsibility, but also really exciting. So, in my conclusion, GPUs have evolved from simple graphics accelerators into central engines driving AI, autonomous systems, digital twins, and the metaverse. Their development shows how innovation often comes when technology finds new applications beyond its original purpose. As future engineers, it's crucial that we understand these technologies, anticipate their impact, and guide their responsible use. By combining technical engineers, um, by combining technical knowledge with ethical responsibility, we can shape a future where AI, autonomous systems, and immersive environments benefit society as a whole. And that's all for my reflection video. And thank you for watching this reflection. I hope you found it insightful and maybe even a little inspired. Thank you.